So yeah, I think I'm gonna do a explanation of the mall. Um, Feel free to ask any questions and stuff like that. It's gonna be probably a highlight on YouTube or something like that. I don't know. We wanted that. Yeah, I think we want one robot board to stand out a little bit. So the automated mall, right? I improved on my version again. I think we did it yesterday. So now we have a min-max system as well. So let's say here I want the minimum of 100 pipes, but build 300 if we have if we go under 100. So the mall is not gonna be building if we take out just a couple. And then the mall starts to build 4 items and then stops again. And then maybe something else needs that, especially with the pipes and stuff like that. Needs those ingredients as well, and then it's gonna build 4 items again. And we didn't want that. So what we made is a min-max system. So it has a request of 152, but we're gonna build 660 because it went below the minimum, but we're gonna build until the maximum. Oh, plastic is not in the network. Yeah, then you can wait until your ash freezes off, I guess. Why is one stacked and one isn't? Because we're not using that lane? We're not using that lane. So let's grab use filter, connect, not use filter, use connection. I want plastic to be in here, and I want it to be 2K. Sorry, mall explanation got interrupted by actually working off the mall. So yeah, we have a min-max system. So first thing first, if you read something from your robot board, always add this combinator, because it will have negative values and that will interrupt with your working of your system. Now, this is our request. Here we are going to have what we want to build. And I tend to now have the storage under it as well. The one gap is for 2 things. if you don't have the jetpack yet, you can walk between it, and it separates a little bit also, so you can easily see which group it belongs to. So let's filter this on something we will not have. So these values we are gonna make negative. Then we're gonna add those values 2 times. So that will be the blue. That will be the green. And then we only want the negatives. Now, these values we need to make positive again. And then one will go here. And the other will go there. Yeah. So now if we need something, it should be on this list. So let's see, we want a Aquilo, we want 200, but we want to build them if Aquilo goes below 10. So here we should have a 10, and there we have a 200. That's the start of the mall. Now, let's bring this back a little bit. Of course you don't have power there. Okay, we'll leave those there. Now, we want to filter out some of the items. So I have a combinator which can be built in other things. So this is the electromagnetic recipe. This is the foundation recipes. So what we want to do is filter out those items from that blue signal, because this blue signal is what we want to have in this mall. So what we're gonna do, we're gonna multiply that by a huge negative number. Then we're gonna take this wire, put it on there. Oh! And only output the positive numbers. So here we have stuff that's built in other machines. So only the stuff that we built in our mall will be on that signal. No, that signal will be... Yeah, this needs to be another color. So if we request green wires, it will not be on this signal. You can see the output of the green wires is not here, or the green things. Now, the basic of the system works on this little combinator. Here we just do the selected input. So if we have, let's say, it's only needed on the blue wire, by the way, for now, because that's what we're working with. So if we have two signals, it will pick one of those two. Highest number first. You can reverse that with this, and then it will show the lowest number first. And we could just, you know, say set recipe. Well, we don't have a recipe for this. Let's see. What can we build that we are... Yeah, mech armor. So now you can build mech armor, right? But as soon as that signal gets overwritten by something else, it will change. And we don't want that. So for that to happen, we need a memory cell. And here we can just say until R is 0, output everything that's coming in. So yeah, now we can add that to the memory cell. But yeah, we need to have a pulse, otherwise this will just add up to infinity. So we need a pulse. And a clock is pretty easy. It's basically 3 combinators, a timer, a memory cell that lets it run until a specific time, and then we can act when that memory cell resets. So now we can have that memory cell as a pulse. So if that dot comes along on the yellow wire, output... Oh, wrong combinator. So now if that dot comes along on the yellow wire, output everything on the blue wire. So now we have a pulse. So we can hook that up again. And now you will see that it will just add it. There we go. Oh, didn't want to do that. But now we have the problem, if that pulse comes along again, we just add it. So we don't want to do that. So we can add a combinator that looks at that one and says, if the blue wire everything into output everything on the yellow wire. So now we have saved that memory cell from recharging twice. Let's make the clock a little bit visible as well. So we can see when it tries to add that number. So now we have a nice way to actually say this is what we're building here. Now we need to separate the signal because we want to know what we're going to build. So that is each plus 0 output each. because we also want to read the ingredients, because we want to request that. So we need to reset you for a bit. There. So now we know what we need to make the armor, and we can read the ingredients. So we can request that in those chests. But what if it's a real simple thing that we want to build? Gears don't show up here. Inserters do. Wait for the light to flash. Wait, inserters do, right? Oh, but we already have inserters in the network. Stupid me. Iron chests. We should not have iron chests in the network. But this recipe is A, really cheap, and it only takes 8 plates. So the moment we bring the 8 plates here and inserts them, we need more. And if you build thousands and it just brings 8 plates in, that's not enough. So I have a little logic. I'm just gonna copy the idea right here that prevents that. So this is a divider. It's the same number of everything. If I change this here, it will change for every freaking output. And it will divide each input here by that number. Sorry about that. So dividing is 8. Now this one here is to be sure if we don't gonna divide it, if we have a really hard recipe, it adds 0. It will output 0. So this is then, if it's 0, just output 1. And here we're gonna multiply the information with the set recipe, and there you can see we need 40 items. So we're gonna request that to those guys, and I set request. So now it's gonna make 40 of those items, or it will gonna request enough for all those items. That's you. Now after this we can just link all of them up, because we don't want to read the ingredients anymore. We don't have to separate that line, and we can just set it to all these chests. Contract all doesn't work that way. Going good, Owu. So now we know how many we want to make. Let's say we want 20. We are explaining how our mall works step by step. So it's now making it, but we still need to reset it. So for that reset, we have a couple of things here. First of all, we check if the in and outputs are aligned. Yeah, that's a delay. Don't need that one. So we're gonna take that yellow and we want to see if that is still on this network. So we still want those 20 chests. We are making chests. So here we can see we have an output of 20. So we're not outputting anything. Because this one will go back to here to reset it. This is just a delay. Otherwise it will just set and reset instantly. And here we can see the difference between what we're making and how many. And this is a real neat trick to just get a signal through from a mother line. So we're making blue chests, or chests, that's on the blue wire. And I want to see on the yellow wire how many I have left. Because this was the ask minimum, so that's what we're gonna build, and this is how many we want to have maximum. So if we delete this wire, it will come in on here with a 2. Maximum is 20 that we want to have, so that's gonna be building. So if we hooked it in, second press please. Oh, we're probably auto-destroying them. Let's make sure we don't destroy them, because that's what's happening right now. There. So now you should see that number 20 will be dropping. There we go. And there it's empty. And it stopped building more. But now we won't build multiple items at the same time, right? Because this only selects the first item, and we want to build more than just one item. And also, we don't want to build the same item over and over. But yeah, let's go first with just, you know, doing the same. Let's not build anymore, actually build anymore. But let's make sure that we do have stuff that we can build. So, but the system doesn't have. So shred those again. So we need our 20 again. You could just go like this and say index 0, index 1. But those indexes changes, and then you're making the same item over and over. Like if we add something to this, like I want 50 wooden boxes. Wait, I do want to set the request, I just don't want you. That's easier to see. Oh, we didn't hook up the wire. Now you can see we're trying to make the same thing again. That's not something we want, right? We don't want to make the same thing over and over. Or in other indexes. So what we're doing is we want that number, what we are building, back on a wire. So yeah, that's that one. So what we are doing, we're making that number that we're building. Yeah, it doesn't matter which wire color we pick here. And we add it to this wire. So that's an easy way to say we don't need this here anymore. But then, what we need to do is remove that from this signal. We do that by only allowing positive numbers through here. And this can just be each at 0 each. Okay, we have to reset them. So now you can see we're making those boxes, and now it's not gonna ask again, because we have those as a negative number. So even if we tick on this signal, those boxes will not be built. What if we had changes in this? Yeah, let's remove you for now. So we're wanting boxes, we are making boxes. That signal is removed. And if we now want steel chests, though it's still index 0. That's why that happened. Yeah, this should be index 1 if you build it like this. So we removed the wooden chest from this signal, so we don't have signal 1, we only have signal 0. And that's going to be a problem, as if that is a 1. So we need something to advance automatically. And that's the first that happened. The index number here. Well, that's easy done. We just change that to an I. Input output I as a 1 if this one is 0. we need to isolate that signal. Just add it like that. And now you can see the boxes will be built on the second row. And that is basically how this works. This is just a reset button. Not really needed. And that's just a display. And this is just to advance the index on this combinator. And here you can see what's built. And if we say off, it will not build anymore until we put it on again. So that's basically how the mall works with all the logic in it. It's not really complex. It's just a few steps to make sure that the information goes right to the right information. And this system we have so we don't build stuff in other malls. If you want to build other machines, the other machine categories, oops, that's not what I wanted. You can just copy those two wires. You can copy basically all of this, but then with the different machines. And here you're gonna say for that blue input, let's say we do the electromagnetic recipes. You just want to have one combinator like that. We need the blue wire to continue, so this will be on the yellow wire. And then here we say for each bigger output each on the blue wire. And that filters out all these items from that blue wire. So if we had an item on the blue wire that matches these guys, let's say solar panels, I want 100, you will see that it only lets that 100 through. And that is how this system now knows what it needs to do. You also need to copy the clock or have that somewhere on a different signal. And then here you can have the other machines building it with the same logic. And also you need to pass the yellow wire, of course, to see when it needs to stop. And that's in this, because we have a min and a max on this setup. So start building at 1K till 1K. You can easily just change this system up if you don't want to set all these max values. You can just say, you know, each times 2 output each, and that is my max value. Also works. Hey Jaeger. Why? What am I doing wrong here? Output is good. Oh, this is minus, yeah. -2 we need to do. And then we have the output. So that's also a way to do it. But yeah, this is how my mall smarts work. And now I need to download the VOD and post that as a YouTube.